Soils. Welcome to Earth Science, everybody. The most exciting thing we have soils. So, what are they? And we're doing this in the last week deliberately because it's kind of a mini little thing, easy enough. If this looks like a lot, don't worry. I'm going to say that this really all comes down to two things. So, let's say like what they are. Soils, a thin layer between the bedrock and the atmosphere. Want those in color? Let's do it. Which is kind of a weird way to define it. That's like where it is. Okay, we got the hard bedrock that underlies everything. You got the atmosphere on top. Well, what's all this stuff in the middle? Which is basically a product of the interaction of those two. And as much as I might say, okay, this is small potatoes, this is no big deal, it's a mini earth science thing, and it verges on what I could probably say you might think is boring. It's also really, really, really critical. Healthy soils take a long time to develop, so, like lifetimes. And if we're going to rely on these soils to feed us through farms, it's probably something that we should understand a little bit, right? So, the big thing, if you just want to say, meh, what's the big thing? Here's how they develop it's due to the weathering of underlying rock and biological activity from life process on top. That's it. And that's probably honestly enough. And this is why I don't spend a ton of time like in the middle of a unit doing this. That's probably enough to get you through all the Regents questions that exist on soils, as you'll find out in the classwork. Um, you know, that you'll know. So let's think about two different areas. Adirondacks, New York. Well, we already know about that. What do they have? They have very resistant bedrock. We talked about that at length. Very hard bedrock, very resistant to weathering because it's metamorphic rock. So that means that if the soils develop because of two ideas, weathering and biological activity, well, weathering isn't happening a whole lot because that rock resists it so much. And there's also lots, abundant plant life. What's the result? And if you ever go hiking up there, you're going to see that the soils are like jet black, a really rich organic soil because there's not a whole lot of the rock material that breaks down to make it into that. It's really just decayed plants, decayed plants, decayed plants. So you get a rich organic soil. Let's do that versus a desert, the Sonoran Desert or whatever, any desert, right? So the bedrock breaks down, but no plant life, or very little plant life. So what's the result? Is really, I mean, it's a desert. You guys know what it looks like, right? It's really just the broken down material. It's just a sandy soil. And how many other types in between? Go and take this at a college level, and you'll be analyzing different types of soils, the different horizons within them, depending on what kind of bedrock is breaking down, what kind of life is on top, how minerals might interact. Around us, we've got a glacial soil because the glaciers came and wiped all the set anyway and dumped that soil, kind of rendering this a little bit non-applicable around here. But still, the very top that has developed in the last 10,000 years would be a result of the breakdown of that glacial mess and organic material. Hey, that's what we're going to talk about right here. One thing to keep in mind, many soils develop in place, some are transported. What could transport soil? As mentioned, the glaciers, since they come pushing through and mashing up everything that they plow through. They pick it all up and they dump it, and that is the result of like most of where we live, this great glacial plain around Lake Ontario. In this case, you will still have soil formation taking place. Rock breaks down / glacial till breaks down. There's still rocks and minerals in there, and life develops organic material. It's just the glaciers brought in that material too. And I suppose I should try to, I don't know where the picture would be, but there's the drumlins, that glacial feature out where I live. I'll find a picture where they're cut off. You can see this because you can see at the top where there's a rich organic soil, and then a very clear, easy to see line below that is all glacial till. All right, so that's it. Again, Mr. F, I didn't want to listen to the first 4 minutes and 50 seconds of that. Those two things. Soil develops because of weathering and life activities. Okay, that covers the whole top. That'll cover you on those questions. How about mass movements? There's a lot we could do here. There's a lot of. I mean, look at all this. I did this just to say, like, here's all the different forms. What it basically represents is Earth materials being pulled down slope. When I taught that disasters course at Oswego, that we dug into this big time. We went deep into it. The Regents doesn't really hit it a whole lot, and again, you'll see those questions in just a few minutes. Basically, saying if you know that mass movements is like soil materials being pulled down slope, there it really is right there before we even fill in any of the blanks. Then you're gonna be fine. Like they don't get into the differences between slumps and soil falls and topples. It's all good. Um, we'll look at I mean, there's some very sad stories. This one in particular is the Ussel one up in Washington State that slid that out. There was a neighborhood here. This was a big slump, kind of right through there, and as it jammed its way through, it dammed up that river at first, but it just shoved a ton of material over like this whole neighborhood. It was rough. This one, same thing. This one's in California. Depending on what the soils are made of, the above normal precipitation maybe, or if there's a strict line between where the soil and the bedrock meet that can kind of like let water accumulate and lubricate it and let it slide down. Anytime you get this downward movement of soil materials, again, we could go more in depth here, but considering where we are and where the Regents is coming at us, let's not beat it to death. This one here is due to permafrost melting. As the Earth has been slowly warming up, the permafrost, the ice that's in some like embedded in some soils is melting, which releases it as water, takes away some of the structural stability, and down it goes. So, all soil materials, again, what we mentioned above, between bedrock and atmosphere, will be pulled down slope. Why? Well, pulls everything downhill here in this universe. Gravity. Okay. And again, some will be slow, some will be fast. If you ever see like telephone poles, gravestones, sometimes if a gravestone is on a hill, do it this way, it'll slowly through the years creep forward. And that's what, check out this diagram a little bit. It talks about the difference between the fast ones and the slow ones. All right. That's really it. One last look. Weathering and biological activity make soils, and mass wasting means things get pulled down slope. With those two, see if you can do those 10 questions. I bet you can. Good luck, everybody.